Vibe coding, viewed as a democratizing development with AI, was coined by Andrej Karpathy in 2025. It represents a seismic shift in software development. Instead of manually writing code, developers describe desired outcome in natural language, leveraging AIs like LLMs to generate functional code. This paradigm reduces barrier to entry, enables non-technical users to become coders and build applications and automate workflows. However, its accessibility raises critical IP questions. What's patentable in vibe coding? Potential possible areas to look at would be technical workflows, unique methods for parsing prompts, refining outputs, or integrating AI-generated code into existing system. For example, a system that converts vague prompts like automate payrolls into secure compliant code by embedding regulatory guide rails would be patentable. You can also have hybrid architectures, combining AI-generated code with human oversight for error correction. For example, you can patent systems that use reinforcement learning to iteratively improve the code quality based on the user feedback. And number 3 is tool-specific innovations. Proprietary features and platforms such as the Cursor composers or Superwhisper can optimize the prompt engineering process, and so those innovations are candidates for patenting. Now, what are the challenges in vibe coding patents? First of all, you will run into the Alice 101 abstract idea rejections. So you should avoid from broad claim like using AI to generate code. Such a broad claim will face the patent office pushback. You need to focus on specific technical problems you're solving with technical improvements that you've come up with. So for example, you came up with a method to reduce API latency by 50% via dynamic prompt optimization. That might be a solution, and then you need to describe how the technology that enables such claims. You also potentially can have prior art overload. With open source tools like GitHub and Copilot dominating, novelty requires demonstration unique data pipelines or domain-specific tuning. So an example is, let's say you have an NLP-driven shopping interface that uses vibe coding to automatically generate inventory APIs. By patenting its cross-platform data aggregation method, Daydream blocked competitors like The Yes from replicating its real-time product recommendations. Next, we discuss patenting opportunities in the vertical AI models, industry-specific moats. So vertical AI models can be tailored to sectors like healthcare, finance, or manufacturing. And those are becoming very popular, and they certainly outpace the generic AI in solving niche problems. These models thrive on domain-specific data and workflows, offering precision that horizontal tools cannot match. So what are the patent strategies that are available for vertical AI? You certainly can do domain-specific training methods, such as, let's say, a startup patents a federated learning system that trains on decentralized patient data and complies with HIPAA. You can certainly do workflow integration and protect how the AI embeds into industry tool. For example, Bloomberg's financial NLP model, which parses earning calls and regulatory filings with context, would be an example of workflow integration with specific steps done to provide the earning calls and regulatory filing. And so that might be a topic for patenting. You might also look at regulatory compliance tools in innovations such as bias mitigation or audit trails, such as, let's say, explainable AI. That would align with the European Union's AI Act. Why patents matter? Vertical AI startups with patents raise 90% more capital according to PitchBook and attract partnership with incumbents. IBM's Watson's oncology diagnostic patents, for instance, enable collaboration with the Mayo Clinic. Trade secrets can complement patents. So for things that are just databases or text information, they're not patentable and you would keep them proprietary. And so in the medical space, an example would be disease biomarkers. Just the biomarker by itself is not patentable, but if you use the biomarker in conjunction with an active step in identifying or treating a disease, then that would be candidates for patenting as well. Next, we discuss robots or physical. The robots bridge digital and physical worlds. And so the AI controls the robot, the drones or IoT devices, and unlocking applications in a variety of fields such as manufacturing, healthcare, and logistics. These systems require seamless hardware-software integration, and they are certainly a fertile area for patent. So there's something that you certainly can consider in the robotic space, sensor fusion architectures. So if you have methods for combining LiDAR, camera, or IoT in real time, that would be a candidate. What about safety and ethical frameworks? Those things are very important in getting the things to work. And human-AI collaboration is another good space because the AI will need some human copilot. The humans will need AI as a copilot. So the challenges in filing AI in the robotic space is that you have a hardware and software dichotomy, and the patent must cover both components. The global standards, and you also need to deal with the global aspects of robots. So how would you handle this? There would be a number of cross-cutting patent strategies you can deploy. For very early technologies, you might want to consider using provisional patents. You can file them early to secure the priority date while you're refining the innovation. And then you can use a layered IP. So you combine patents with a trade secret. So i.e., your training data set may not be patentable, but you can keep them as a trade secret. And then you have the patents on the things that are customer facing where they can reverse engineer your idea. You can also patent a bias detection tool for sustainability features or to deal with regulatory risks. So in the road ahead, what we expect is significant growth in vibe coding, and we expect patents for self-refining AI that learns from code-based evolution. You expect the vertical AI, such as the specific industry applications like healthcare and manufacturing, for example. And we expect significant physical HEI in humanoid robotics and edge device optimization. So in short, in the AI area, patents are not just legal safeguards, they are strategic assets that validate innovation, attract investors, and define market leadership. Whether you are democratizing the AI technology with Vibe tools, or you optimize supply chains with vertical AI, or build the next generation of humanoid robots, a robust IP strategy is the ultimate moat. As Andrej Karpathy noted, the hottest new programming language is English, but the hottest new competitive edge is a well-crafted patent portfolio. By marrying technical ingenuity with IP savvy, founders can transform today's prototype into tomorrow's protected unicorns. The future belongs to those who code, model, and build patents in hand. If you need any assistance or questions, please reach out to us. Thank you.